Yes, students. So day 2 became late today. Okay, let's try and cover it up. So in yesterday's class, we said that vernier calipers and screw gauge we are going to see today. Okay. So vernier calipers, I hope every one of you have seen, practicals you have done, practicals you have finished. So you know that. Okay, this is vernier calipers. What is difference between vernier calipers and meter scale? This is more precise. You can measure even up to 0.1 mm in this. Okay, so what is the minimum we can measure through this vernier calipers? 0.1 mm, and that 0.1 mm only is least count also. Okay, that is least count of vernier calipers, 0.1 mm. How this least point comes? Okay, so least point or least count rather is actually what is the minimum you can measure on meter scale? Minimum you can measure on meter scale 1 mm. Okay, divided by the number of divisions in vernier scale. Okay, you can say least count of meter scale by number of divisions in vernier scale. Least count in meter scale by number of divisions in vernier scale. Okay, this used to be 1 mm, we discussed it yesterday, and this is actually 10. So it becomes 0.1 mm. Okay, this is also one of the way. Another way is also there in which we measure least count. What is that? And many questions before have asked on that one. Least count is what? This is actually 1 main scale division minus 1 vernier scale division. 1 main scale division minus 1 vernier scale division. Okay, how to find it? This is one formula, but they use it in numerical. How will be the numerical given to you? Okay, so let's see then if we are going to frame one question. How is the question? Question is like this. Suppose I am writing it on this screen only, the question. It says that 19 divisions of main scale coincides with 20 divisions of vernier scale. Find least count. Find least count. Or you can say that n divisions of main scale coincides with n plus 1 divisions of vernier scale. Find least count. Okay. So now what he says, 19 division of vernier scale or rather main scale are coinciding with what? 20 divisions of vernier scale. It means 19 main scale divisions are equal to 20 vernier scale divisions. Okay. So from here, what is one scale division? One vernier scale division? We can say 19, bring it here 20, main scale division equal to 1 vernier scale division. So in terms of main scale division, we know what is vernier scale division. Now what? Least count. Least count is what? 1 MSD minus 1 VSD. So MSD we will write as it is, no change. Minus 1 VSD is what? 19 by 20 MSD. So 1 minus 19 by 20 means 1 by 20. 1 by 20 of MSD. Now what is MSD? It will be given to you. It will be given to you in the question. They will say that 1 MSD is equal to maybe 1 mm or 0.5 mm, whatever, depends on that scale that we have. So we can write it over here. If suppose it's 1 mm only, so it's 1 by 20 into 1 mm. So this will be our least count. Very, very important. Okay. Many times this types of questions are asked on least count. So what I told you, least count, two formulas. One, What is the minimum you can measure on meter scale? That is least count of meter scale by number of divisions in vernier scale. And another one is 1 MSD minus 1 VSD. And if this is given, how they will give you? These many divisions of main scale are coinciding with these many divisions of vernier scale. Find out 1 VSD, keep it in the formula, you will be getting the answer. Okay, let's come to this one. How to measure? Okay, if vernier scale is given, vernier calipers is shown to us, and it is asked from us what is the reading of the vernier scale. How to do it? And moreover, what we do with this vernier scale, we measure the diameters of the balls. Okay, if you have done simple pendulum experiment, this is how we measure the diameter of the bob. Okay, diameter of the bob, diameter of the cylinder, okay, length of small cylinders maybe, okay, all these we find with the help of this. So how to see the reading? Now see then, in this one, what we have done, this is main scale and this is vernier scale. So when not in use means is both this jaw and this jaw, these are two jaws, okay, this is inside jaw, this is external jaw. So these jaws are in touch with each other. When both are in touch with each other, we will say that they are not in use. When they are not in use, 0 of both will coincide. So reading is 0, right? But when we are using them, suppose at the moment this is the same thing here, okay, you have put one ball over here, some main scale reading is there, this is vernier scale reading is there. Now two things are here, this is main scale 0 here and this is vernier scale 0, okay. When they were not in use, you said that both zeros are coinciding, not in use. But when we are using them, now you see that this is 0 of main scale, this is 0 of vernier scale, both are not at the same place, right? So now we have to see the reading. What is the reading? You can see that. First thing is you need to find out that where is 0 of vernier scale. You said 1, 2, 3, 4, 5. Okay. So this is reading of main scale. What is reading of main scale? 1, 2, 3, 4, 5. Okay. So what? 5 is what? 5 mm. Because this is centimeter scale. This is 0 centimeter, this is 1 centimeter, this is 2 centimeter, this is 3 centimeter. So 1, 2, 3, 4, 5. What is that? 5 mm. So main scale reading is 5 mm. Is that all? Answer is no. Because it's not exactly coinciding, slightly this side is the 0, 1, 2, 3, 4, 5 and this 0 is slightly beyond that. In addition to that also something is there. So that addition, that's why we are using this vernier calipers. No? If this much only we have to find, we would have used meter scale. It would have given us 5 mm. More than that, how much more than that? For that only we are using it, right? So now how much more is that? For that what is to be done? What is the procedure? We have to find out that which division of vernier scale exactly coinciding with any division of main scale. That is what they are, no, 19 divisions of main scale coinciding with 20 divisions of vernier scale, right? So here, which division of vernier scale is coinciding with any divisions of main scale? You say that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which one is there? I think first one is only one on the other, right? This only is one on the other. So that means vernier scale reading is 1. One what? No, only one. Don't put mm or anything. Now what is the reading? Final reading is what? Final reading is main scale reading plus vernier scale reading into least count of vernier calipers. Okay. So main scale reading is what? 5 mm plus vernier scale reading is what? 1 and least count is what? 1 by 10 mm, 0.1 mm. What is the answer? 5 plus 0.1 mm. That is 5.1 mm. is our answer. So this is how we use vernier calipers. First, find main scale reading, then vernier scale reading, that means which division of vernier scale is exactly coinciding with main scale, find it out, then put it into this formula, you will be getting the reading, right? But there is one more problem in that. That problem is called zero error. Zero error means is what? When we are not using vernier calipers, zero should be like this. Both zeros should be one on the other one. But sometimes, because you are using the instrument again and again, many times you are using it, some zero error comes in that. Zero error means is these zeros are not going to coincide. Let's see. Okay, zero errors are there because zeros of both the scales are not coinciding. Two types of zero errors, positive, negative. Okay, now in this one, you can see that this is vernier scale, that below, and upper one is main scale. So what is here? You can see that zero of vernier scale is on the right side, of main scale 0. So what we are calling it as positive zero error. So 0 of vernier scale is on the right of main scale 0, we are calling it as positive zero error. And if the 0 of vernier scale is on the left of the 0 of main scale, then we are calling it as negative zero error. Now what to do? No problem. First, we have to measure how much is zero error. How much zero error is there? But we should know negative is there or positive is there. That's very necessary. So that's why I am showing you. If the vernier scale 0 is on the right, it is positive zero error. If it's on the left, it's negative zero error. Now the question is how to measure it. Very simple. Same way we have to measure. We have to take the reading of vernier calipers. Same way. So here what? What is main scale reading in this one? Main scale reading is 0. Okay. We have to see that where is vernier scale 0 in that one. 0 plus something. So main scale reading is 0. Now what is vernier scale reading? Again same thing. Which division of vernier scale is coinciding with any divisions of main scale? Let's see which one. This second one, this. So vernier scale reading seems to be 2. So what is zero error? Zero error again, main scale reading plus vernier scale reading into least count. What is main scale reading? 0 plus vernier scale 2, least count is what? 0.1 mm. So that means zero error is 0.2 mm. Same way here also, exactly same way. See that now. Here also, what is reading? What is main scale reading? 0. 0 only. Vernier scale reading you check. Same method. Okay. This. Which one? Third only is looking the perfect one. Check. This is third. Second one is also looking it like this. But I am taking third. Okay. Let's say vernier scale reading is 3 in this. Again, zero error is what? Same way. Main scale reading, which is 0. Vernier scale reading into least count. No difference in calculation of zero error. But remember, this is negative, this is positive. Now, how to find final answer? Final reading. Now, in final reading, what will happen? Zero error when you have calculated, after that you forget it. Forget it. And now, calculated this value in the same way. You have kept one bob over there, then you found main scale reading, then you found vernier scale reading, you calculated this came. Now we have to adjust the zero error. So final reading is what? Final reading is this reading minus zero error. Whatever zero error we have calculated, we have to subtract. Whatever zero error is there, we have to subtract. So what will happen? Let's come over here. We are talking about positive zero error. This is 0.2 mm. This we are going to subtract. What about negative zero error? Negative zero error, we always take it in negative. This is negative. So this is negative. So negative 0 error actually is getting added and positive 0 error will be subtracted. Okay. Formula is reading minus 0 error. Negative 0 error is negative. So you will be adding it. Positive 0 error is positive. So it will be subtracted. Clear? This is vernier calipers. Then we have screw gauge. Even more precise you want to go. Vernier calipers you are not happy. You want more precision. Okay, more accurate reading. So we have screw gauge. But screw gauge is not used for the same purpose as vernier calipers, because in vernier calipers you can find the diameter of slightly larger objects. This is used for very, very smaller objects. That's why you require precision, right? So diameter of the pin. Okay. So in this one, what is there? In this one, setup you all know. I don't have to tell you what it is. You must have seen that in lab. Okay. So in this one, this I can say this is a spindle, this is anvil. If you are not using, both have to touch with each other. And 0 of main scale and 0 of vernier scale, not vernier here, circular scale. They have to coincide. When you are not using them, they need to coincide. Okay, this is main scale here, this is circular scale, and this is ratchet. When you are touching the spindle with anvil, or you are in touch with the object. Okay, first it is touching the object slightly. We have to rotate it to see that there should not be any play between them. That's the ratchet. Fine. So this is screw gauge. Now what about its least count? So its least count is what? Same thing. Okay. How much least this can measure? This is actually meter scale. Main scale means is meter scale only. So least count of meter scale by number of divisions in circular scale. Number of divisions in circular scale. Circular scale. So least count of main scale is what? 1 mm, and number of divisions in circular scale 100. So what minimum we can measure? 0.01. In vernier calipers 0.1 mm. Here 0.01 mm. Okay. In meter scale 1 mm. Vernier calipers 0.1 mm. 0.01 mm. So what you see that precision is increasing. Okay. Right. But in books it is not given like least count or meter scale. They give something like pitch. Okay. You can say pitch also. By number of divisions in circular scale. What is pitch? Pitch basically is if you are rotating it once, one rotation of this, okay, makes it to move ahead by 1 mm only. And 1 mm is the pitch. What is pitch here? If you rotate this by once, how much distance it moves ahead? That's called pitch. Alright. So in one rotation, distance moved by your circular scale is called pitch. Right. How to measure this one? Simple, the same method. What is that? Reading will be main scale reading plus vernier scale or circular scale reading into least count. Okay. So reading is main scale reading plus circular scale reading into least count. Right. Clear? In this also 0 error is there. Yes. In this also 0 error will be there. Okay. So how to see what 0 errors? Here it is. Positive 0 error, negative 0 error. Now what is there in this? You have to see. Main scale 0, circular scale 0. Circular scale 0 is below main scale 0. What error? Positive 0 error. Here you see, where is main scale 0? This is vernier scale. sorry, not vernier scale, circular scale. Okay, so this is circular scale. So what is here? Circular scale 0 is above main scale 0. Here below, here above. Below means positive, above means negative. How to measure it? You all know that. Okay, see now. So if 0 error we have to measure here in this one, we have to see that how much divisions below is circular scale 0. This is 1, 2, 3. 1, 2, 3. Right? So what is 0 error? 3 into least count. What is the least count? 0.01. So 3 into 0.01. Okay. In this one you see, this is main scale 0. So how much above is this circular scale 0? 1, 2. So 2 into least count. Negative 0 error, as I told you, it will be taken in negative form. So negative we have taken. Positive means we have to take it in positive. Final answer, if we have to adjust 0 error, same way, no change. Okay. So final reading is normal reading you have taken. Okay. Then minus 0 error. And this reading is what? Reading means what? Main scale reading plus least count into circular scale reading. Okay, main scale reading will be what? Main scale reading here, notations are there. We'll go back and check. Here notations are there. Okay, now in this one, if suppose main scale reading we have to check. Now this is 0, 1, 2, 3, 4. Main scale reading is 4. Correct? This is main scale reading 1, 2, 3, 4. 4 plus something is there. Then we will see circular scale reading. Now circular scale reading is also what? It's where it's meeting. It's even less in this one, which exactly is pointing out that we have to see. Right or no? So what it is? We are not able to see here because that's also in the middle. So we'll say vernier scale reading is what it is. 4 plus main scale reading is 4. Now circular scale reading is how much here? How much below is 0 of circular scale as compared to main scale? Less than 1. Correct? Less than 1. So what to say? Suppose it is 1. Suppose it is slightly below. Okay. We can say that it is okay. Plus 1. So we will take plus 1. So main scale reading plus circular scale reading into 0.01. So 4.01 mm we can say. Right. This is how we measure it. So that's the part of measurements we have done. But today main topic is 1D motion. This we have to study. Okay. So what is 1D motion? 1D motion means one direction motion. Straight line motion, you can say that. Straight line motion. So first thing, we all know that this chapter starts with displacement and distance. So distance basically is what? Path length. Length of the path. Total how much length of the path you traveled. Okay. Displacement is what? Shortest distance between initial and final point. Initial point and final point. Right. This is scalar. This is scalar quantity, whereas this is vector quantity because direction matters in this. Because it's the shortest distance, so direction matters. Correct. This is scalar, this is vector. Then what else we can say about them? We have to understand. What is that? Let's see. Okay. So if suppose we are going to put over here that we are starting from this point. Okay. This is our initial point. And final point is on the diametrically opposite point. This here. This is final point. The radius we can say is r. So if we have to find distance and displacement, how much distance we have traveled? So distance traveled, not a long thing, distance traveled. You went like this. Okay, so distance traveled is how much? Distance traveled is say pi r, half of the circumference. But if I have to find the displacement means shortest distance between 2 points, this point and this point. What is the shortest distance? This is shortest. This is small as compared to this one. So displacement is what? 2r. And what is the direction? Direction is always from initial point to final point. Okay, displacement is direction. Direction is always from initial point to final point. Initial point to final point. Okay, if suppose now I say that you've traveled further, you reached over here, FP dash. Okay, now if I have to find the distance traveled, say this plus this plus this, right or not? So this is pi r, this is what? Pi by 2r. So pi r plus pi by 2r, that means 3 by 2 pi r, right? So distance IP to FP dash, this is how you traveled. The distance is what? 3 by 2 pi r. But if you are talking about displacement means, as I said, direction is always from IP to FP and shortest distance. So it's like this. So this is the direction. And how much is that? If you see in this one, this if I have to measure, I'll be joining it like this. This is r. This is also r. Then what will be this? Pythagoras theorem we'll use. This is right angle triangle. So this is hypotenuse. This is root 2r. So in this case, displacement I have to write from IP to FP dash. It will be what? Root 2r. Right? Distance and displacement. Correct or not? More we will see. Now see that this thing is clear to us. This is shortest distance and direction is always from initial point to final point. Whereas this is length of the path. There is no direction in it. Distance is always positive. We'll see that. Okay. We'll see that. So let me clear this one and explain in another way. What is another way? Let's see, make coordinate system and try and understand. Okay, this is along x-axis. Right. So this point is you take as O. So what happened is one particle is moving from O to A. Here you take A. Okay. So let's say this is 100 meter. Okay, and this point is B. Let's assume this is 40 meter. Okay, and this point here is C point, just 20 meter. Okay, now I am going to ask you, like, what is distance OA? The distance OA means you traveled OA. How much is that? 100 meter. 100 meter. If I ask you displacement OA, displacement OA, that's also 100 meter. So that means distance and displacement can be equal also. Yes. When there is no change in direction, both are equal. Distance OA and displacement OA are equal here. In the previous case in circle we saw that. Were they equal? They were different. Reason? Because direction was continuously changing. Direction of motion was continuously changing. So distance and displacement values were different. But here you see, straight line, value is same. Okay. Alright, now let's talk about distance OB. The distance OB is what? You travel like this and then you are turning back. Okay, first you went like this and now you are coming back. So when you talk about distance OB, there is OA plus AB. Say OA plus AB. OA plus AB is how much? 140 meter. Okay, what about displacement AB? Oh, sorry, displacement OB. Displacement OB is this. This is initial point, this is final point. So how much is that? 60. And direction is always from initial point to final point. So if direction also I have to give, then OA also I should give the direction, right? So then I should write as a vector. 100 meter into what we will write? I cap. Along positive x-axis we will write I cap. Here also along positive x-axis, so I cap. So OB is like this is a vector. Magnitude you see is different. Let's talk about OC now. Distance OC. How much is distance OC? OC means you will be coming here. So 100 meter, then you are coming back 100 meter and traveling 20. So 100 plus 100 plus 20. So distance traveled is 220. What about displacement OC? Now displacement OC means this is your initial point, this is your final point. Initial, final. So this is 20 only. So 20. Magnitude is 20. What about direction? Minus I cap. So you see that how much is the difference between distance and displacement. So what you understood? Distance and displacement magnitudes are same if the direction is not changing. If direction changes, displacement is always lesser than distance, right? So if I write, suppose any x I am writing, this is vector, so that means displacement. Displacement is always less or equal to distance. Okay, less or equal to, when equal to? When direction is not changing. Okay, when direction changes, its magnitude is always less. This is displacement. Correct? Understood that? Right? Okay, let's move ahead. Speed and velocity. Okay, speed and velocity. Now what is speed? Speed is distance traveled per unit time. Distance traveled per unit time. So it depends on distance. So since distance can never be negative, speed also can never be negative. It's always positive. Scalar. So scalar quantity. It's a scalar quantity. But in this speed, we have got two things that we normally undergo. One is called average speed, another one is called instantaneous speed. So let's write the formula and then try and understand that. Okay. So what is the formula of speed? I am going to write this as V. Okay. So V is distance traveled. Okay. The distance traveled, right? Or path length you write, that will be better. Path length by T2 minus T1. T2 minus T1 means is what? Because we know that you have started the journey at, let's say, 12 o'clock and you reached your destination 12:30. So what is the duration? Half an hour. But what you did? 12:30 minus 12. So 12:30 minus 12. So T2 minus T1 or delta T, right? So path length by T2 minus T1. This is the formula of speed. Okay. But when you are going to talk about instantaneous speed, instantaneous means what? Instantaneous means is speed at a particular instant. Okay. What is instantaneous speed? Speed at a particular instant. Speed at a particular instant. Now when you say particular instant, what happened here? It means this T2 minus T1 have become very, very small. This T2 minus T1 has become. Instant means what? Fifth second. So what is T2 minus T1 in that? Very less. Maybe fifth second means maybe T1 is fifth second and T2 is 5.0001, right? So delta T is very small. So we write it as what? We will be writing V instantaneous. This path length we have to write now. And when you talk about instantaneous, though in that instantaneous change in direction is not possible. Not possible. In that fraction of second you can't change the direction. Okay. So remember, instantaneous speed and instantaneous velocity's magnitude will be same always. Instantaneous speed and instantaneous velocity's magnitude is always same. Formula also dx by dt. Formula also same, dx by dt. Instantaneous speed, instantaneous velocity. But velocity is vector. What will be the direction? Direction will be along length of path length, along the path. Okay. So instantaneous velocity, if I am writing, it's also dx by dt, same, no change. But this arrow represents what? Direction is along the path. Along the path. So what is the difference in that one? We saw till now distance and displacement will be equal in terms of magnitude when direction is same. But here I am saying instantaneous speed and instantaneous velocity are always equal. Clear? Because it's for fraction of seconds, and in that one you can't change the direction. So that's why their magnitude will always be equal. Okay, so this is instantaneous. Instantaneous speed also I told you, instantaneous velocity also we discussed. Only difference is we'll write velocity at a particular instance. Velocity at a particular instant. Okay, let's move forward. Okay, we have a question now. So what's given? It's given to us that position of a particle at any time is x equal to 2t square plus t. Okay, x equal to 2t square plus t. Find v at t equal to 1 second. This is velocity. Find velocity at t equal to 1 second. Okay. Now what to do? T equal to 1 second means, is he asking instantaneous? Answer is yes. Yes. Otherwise he would have asked between this and that. So t equal to 1 second, instantaneous. X is given. What to do? He said instantaneous is dx by dt. So what we have to do? We have to differentiate them. So I am assuming that every one of you know the differentiation. Okay. If you do not know the differentiation, I will give you the link of the class. You go and see that. Okay. So v instantaneous is dx by dt. So we are going to differentiate it. Very simple it is. 2 is as it is. Differentiation of t square is 2t. That's all. Then plus differentiation of t is 1. So what we got? 4t plus 1. T equal to 1 is given. So 4 into 1 plus 1, that is 5 meter per second. This is the velocity at t equal to 1 second. Okay. Just a minute, student. Just a break for water. Right. So now this is how we got instantaneous speed or instantaneous velocity. If we say it's moving along positive x-axis, we are seeing that it is positive. X is always positive. Why always positive? Because time will always be positive. Time cannot be negative. So this also positive, this also positive. So x is always positive. You will say v is also positive. So if you want, then he is asking velocity. So we can say, okay, v equal to what? Say 5 I cap meter per second. It will move along positive x-axis. So we said that, okay, 5 I cap. Okay. So this is it. Then another question. If x equal to 12t square minus 6t, when object will come to rest? Okay. Position of the particle is given as a function of time. He is asking when object will come to rest. We know that object will come to rest when velocity will become 0. Okay. When velocity will become 0. So first we have to get velocity, then which velocity? Instantaneous velocity. Okay. So what we will do? Instantaneous velocity means dx by dt. One more time, that means 12 differentiation of t square is 2t minus 6 differentiation of t is 1. So v is coming as 24t minus 6. Now we are saying when object will come to rest. Object will come to rest when v is 0. So when v is 0, put v as 0 here and see 24t minus 6. So t equal to 6 by 24, that is 1 by 4 of a second. So object will come to rest in 1 by 4 seconds. That's what he wants. Yes, we calculate it. Okay. Right. Let's move ahead then. What else? We have average velocity and speed now. Okay. So we did discuss average velocity. We discussed about speed and velocity and instantaneous speed and velocity. Okay. So what is average speed? This is average speed for me. VAV. What is VAV? It's a total distance traveled or total path length. Total distance traveled by total time taken. By total time taken. So in this one, this time is huge. Huge means it's considerable, not huge always. Can be huge also. Can be in hours. Something like if train we are traveling, 24 hours you were in the train, and in 24 hours it travels 2000 kilometers. So what will be average speed? Say 2000 kilometers by 24 hours. Right? So that will be average speed. Average velocity then? Average velocity, total displacement by total time. Okay. Average velocity magnitude I have written, that's why I am doing all this. So average velocity is magnitude is equal to total displacement magnitude by total time. Vector quantity, yes. Scalar quantity, same. There is no change as far as the properties are concerned. This is scalar, this is vector. Right? Total distance traveled by total time, this is total displacement by total time. And again, the value of V average will always be less or equal to. If it's equal, that means in total whatever duration you are taking, direction is not changed. It's in straight line. So they can be equal also. But if the direction is changing, this will always be less than this. Plus V average, this value, cannot become 0 if the body has started moving. This can never, we know that it can't be negative, but it can't be 0 also. If the body has moved from its initial place, V average cannot be 0. V average means speed I am saying. But this one, it can be 0 because you can return back to the same position. So this always can be negative, can be positive, can be 0. Whereas this is always positive. Always positive. Cannot be 0 if object has moved. If object has not moved, then it's fine. You can say it's 0. But if object has moved from its position, it can never be 0. Who? Speed. Clear? Okay. So here is a question for you then. What is the question? You can see there is a circle, or you can say as a ring. There is point P here. Find average displacement of point P. So what is happening here? This is actually rolling. Rolling means is like this, it's moving ahead. Okay, like this. So this point P is reaching over here, but at the same time this is moving ahead also. What we have to do? We have to find displacement of point. What is the displacement? Displacement is always shortest distance between initial and final position. This is final position, this is initial position. That means this is what we have to find. Do we know this one? Yes, we know this is diameter, so it will be 2r because radius is given. The question is, how much is this? So how will we find? We have to see that how much minimum you rotated so that point P reached over here. Half. If suppose this is not moving at all, then we'll move it like this. It will reach over here. When it will reach over here? When you are rotating it by half. Correct or not? So that means you have rotated this circle by half. That's why point P is here. But at the same time, you have made it to move ahead also. How much it has moved ahead? Half of circumference. Half of circumference. So this is what? Pi r. So this will be pi r. So displacement, this is the displacement. So Pythagoras theorem we will use. What is displacement? Displacement will be square root of pi r whole square plus 2r whole square. That's all, finished. So this is pi square r square plus 4r square. R you take common. So r root over pi square plus 4. That's the answer. That's the displacement. Common question. You can find this everywhere almost. Okay. So displacement is pi r. This is we found with the help of Pythagoras theorem. So square of this plus square of this is equal to square of this. Right? Okay. Let's move ahead. Okay. This is also a common question. If car covers half distance with 20 meter per second and remaining half with 60 meter per second, what is average speed? Not average velocity, average speed. Okay. So half distance, let's say total distance is x. So half the distance with 20 meter per second and half the distance with 60 meter per second. What is average speed? V average we know. Total distance by total time. What is the total distance we have taken? Already we have said that it is x. So x. Now if I say that this is O, this is A and this is V. Okay. What we will do now? Because total time we have to find. So we will say time in moving from O to A plus time in moving from A to B. Okay. So what is the time taken to move from O to A? Time taken will be distance by speed, because here I know speed and distance also I know. This is x by 2 given to us. Okay. So time we can find, distance by speed. Okay. So x by 2 by 20 plus, in this one also we know the speed and we also know the distance. So here also time we can find. What is that? X by 2 by 60. Correct. That's all. So x, now here we have to take LCM. What is this actually? X by 2 by 20 means x by 40 and x by 2 by 60 means x by 120. The solution will be what? Their LCM is 120. This is 3x and this is x. So we'll write 4x by 120. We take 120 out. X cancel. Answer is 30. 30 meter per second is the average speed. Right. So main formula is total distance by total time. And if they are saying us to break it, like they said no, half distance with this, half distance with that, so break it. Fine. So break it means this total time we are breaking it 2. Time in from here, time in from here. Correct? Okay, let's see further. If velocity is given as 1 plus t, what is the distance traveled by body in first 2 seconds? He is asking distance traveled. So first thing is, can he ask displacement also? Will they be equal or they will not be equal? How to find it? That I will tell you. Okay, so first let's solve. This is velocity and he is asking distance. And is this velocity variable velocity or constant velocity? Variable, because time is changing. T equal to 1 second, its value will be 2. T equal to 2 seconds, its value will become 3. Okay, variable velocity. So what we can do? We are going to write this as dx by dt. Okay, so we have written this as dx by dt. Then what we have to find? Distance travelled or displacement travelled? So we are writing dx equal to 1 plus t dt. Now it's the opposite process. This is what we have to integrate now. We have to integrate. So from wherever you are starting, we are calling it as 0. So 0. And here it becomes delta x. Displacement or distance travelled. Okay. Here he says 2 seconds. So initial is t equal to 0 and this is t equal to 2 seconds. We have to integrate that. But now as I told you that distance and displacement, will they be equal or they will be different? How to find? That decides by the direction. If the direction is changing, then displacement will be different. If direction is not changing, it's same. So check over here. Is the direction changing? Velocity, no? 1 plus t. T, can that be negative? T can never be negative. T is always positive. So if this is always positive, that means velocity is always positive. In this particular question, the velocity is positive. That means distance and displacement will be same. Will be same. Okay. So we are not bothered. If he is asking displacement also, we are not bothered. Okay. Right. So now integration of this. And this is what? 1 dt. So we will write dt only plus t dt. Okay. dt's integration is t. Limits 0 to 2. Here t dt is integration t square by 2 and this is 0 to 2. What's coming? Put here higher limit minus lower limit plus t square. So first 2 square minus 0 square by 2. What's coming? This is 2 here. Here is also 4 minus 0 by 2. That's also 2. So 2 plus 2 is coming 4. 4 meter. So displacement is 4 meter. Distance is 4 meter. No change in this question. Okay. So distance and displacement both are equal and they are 4 meter. Clear? Okay. A velocity is 2t plus 3t square. Again you see there is no negative anywhere over here. So velocity and speed, they will be same. What is the question? If v equal to 2t plus 3t square, what is average speed? Oh my god. How to find? This is instantaneous. How to find average speed? Average speed is what? Total distance traveled by total time. So first we have to find total distance. How to find total distance? We didn't know in the previous question. Distance and displacement were equal in that, right? So here also same method, no change. Dx by dt equal to 2t plus 3t square. Dx equal to 2t dt plus 3t square dt. I reduce one step. Okay. 0 to delta x. 0 to 2. 0 to 2. Okay, so integration 2t square by 2 plus 3t cube by 3 this and this is cancelled, this and this is cancelled. Limits 0 to 2, 0 to 2. So what we are getting here? 2 square minus 0 plus 2 cube minus 0. So 4 plus 8, that is 12. 12 meter is the distance you are traveling in 2 seconds. But is he asking distance? He is asking average speed. So V average is what? Total distance by total time. How much is total distance? 12 time 2. Answer. So this is basically instantaneous speed. How to calculate average? Total distance you have to find. Total distance means, if suppose from instantaneous value average I am writing. Average we represent like this, okay? This is average. What is that? V dt by dt. This is the method. This we are going to use throughout physics. Whenever you have to find average, something like this only we write. V dt by dt. V dt means actually here displacement, or here in this case distance. Okay, the total distance by total time. That's what we did, no? This is what V dt only. Okay, this see, I'll show you. V is dx by dt. That's what we have written here. So dx is what? V dt. See. So in place of dx, I have directly written here V dt by. Okay. Right. Acceleration. Okay. What is acceleration? Acceleration is vector quantity. Yes. Okay. What is acceleration actually? It's a measure of change in velocity. Measure of change in velocity. Okay. So acceleration basically is delta V by delta t, or V2 minus V1 by T2 minus T1. So this is change in velocity. Its direction, it's a vector quantity here. What about its direction? Towards east positive, towards west negative, towards north positive, towards south positive? No. It doesn't depend on that direction. Then it depends on change in velocity. If change in velocity is positive, acceleration is positive. If change in velocity is negative, acceleration is negative. So if velocity actually is increasing, that means obviously V2 will be more than V1. So if V2 is more than V1, acceleration positive. If V2 is less than V1, acceleration is negative. This is how acceleration is decided. Not like positive x-axis positive, negative x-axis negative. It depends on speed, depends on magnitude of velocity. Okay. So does it depends, acceleration will be there only because there is a change in speed? No. Acceleration will also be there if there is a change in direction. Okay. So acceleration is there when there is change in direction, when there is change in direction, or change in speed, or both. Okay, so sometimes we will say that okay, there is in circular motion, we say no, if circular motion is there. In circular motion, what's happening? We say that speed is constant. Constant speed. Acceleration is there or not there? It's there. Direction is changing. Okay, so because change in direction is there, acceleration is there. Right, so remember that acceleration is a measure of change in velocity. Can be 0? Yes. Can be positive? Yes. Can be negative? Yes. No doubt about that. Okay, so acceleration is v2 minus v1 by t2 minus t1. Right, then, all right, question on acceleration. Acceleration is given t minus 2t square. Now you see that acceleration is a function of time. It means it is average acceleration or instantaneous. Answer is instantaneous. So instantaneous acceleration means what? So dv by dt. One more formula is there, v dv by ds. Okay, so if acceleration is given in terms of position, then we use this formula. Which one? This one. And if it is as a function of time, we use this. Both are important for us, so you should know both. Okay, when acceleration is given as a function of time, use this formula. If it's given as a function of position, we'll use this formula. But what it is? Instantaneous. Instantaneous. What he wants? What is velocity at t equal to 1 second? Fine, no problem in that. So acceleration we will write as dv by dt equal to t minus 2t square. Okay, so dv equal to t dt minus 2t square dt. Now here this is dv. What it will give us? Change in velocity. Change in velocity. Okay. So that means initial velocity u, final velocity v. 0 to 2. 0 to 2. So on the left hand side, what is going to come? It's also integration only. So its integration will be v and limits are u and v. Here it's integration t square by 2. Limits are 0 and 2. Here t cube by 3, 0 and 2. Right. So on the left hand side, what is going to come? First you will place v, then u. So left hand side will give us v minus u equal to, yeah.
The time is 1 second.
Time is given 1 second. Okay, we'll take 1 second. No issue in that. This will remove 1, 1, 1 and 1. Right? Okay. So now what? This is v minus u. Now put the value here. So 1 by 2. First you are putting 1 minus 0. So there is no need to write 0 over here. So it's in 1 by 2. And here minus 2 by 3 already. Okay. Then after putting limit 1. 1 cube is 1. Okay. What we are getting? Something in negative it's coming. 1 by 2 means 0.5 I am writing, and this is 0.66 I am writing. So it comes out to be minus 0.16. What is u? U value given to you. Put it. V minus 5. So what is V? 5 minus 0.16. It will be 4.84 meter per second. Okay, here it's given. You see that u value is given already, and he is asking v. What will be the velocity after 1 second? We found it. So whenever acceleration is there, x is there, or v is given as a function of time, that means immediately that should come into your mind that derivative is going to be used. dv by dt, okay, dx by dt, something we have to do. Clear? Okay, let's move ahead. Okay, now next is we have to study about graphs. Now basic terms we studied: speed, velocity, acceleration we discussed. Now graphs. So which graph we have first? Position time, xt graph. Next t graph, okay, first graph I am making, xt. Graph is like this. So what it says? Okay, any graph, when you are seeing, there are two things that we look into any graph. What are two important things? One, slope, and second thing, area. What does slope means? Slope means is tan theta. Tan theta of graph. Now you say tan theta graph means what? Tan theta of graph means change along y-axis whatever you have written by change along x-axis whatever you have written. Okay, so change along y-axis. Now y-axis means is vertical. Okay, now it's possible that in some question this is y-axis and this is x-axis and you say that's it, sir, you said that along y-axis. No, y-axis means is vertical. Okay, change along y-axis by change along x-axis. So in this, if I am going to write in this one, tan theta basically your slope is actually dx by dt. And this is change along y-axis, this is change along x-axis, dx by dt. And dx by dt actually is what? What is dx by dt? Velocity. Velocity only, no? Check, we have discussed this already. Where is velocity here? Dx by dt, where we have written? Here we have done. See, velocity is dx by dt equal to 1 plus t. Correct? So velocity is dx by dt. So slope of xt graph is velocity. Okay, in this case, this is xt, no? So this is velocity. Now let's try and understand the graph that I have shown you. Here, what is the slope now? Slope means is the angle this is making with the x-axis. Theta. Theta means angle this is making with the x-axis. So angle is 0. They are parallel. They are parallel. Parallel means V is 0. V is 0 how? Because theta is 0 means tan theta is 0. Tan theta is 0 means velocity is 0. V is 0. That means it is at rest. At rest. Okay, so this graph shows you that the particle is at rest. So okay, fine. Then other graph we'll make here. Okay, same xt. And this time we'll make it like this. This is the graph. Now what we can say in this one? In this one I can say that slope is constant. It's a straight line, no? Whenever it's a straight line, slope will be constant. Okay? Graph is a straight line. Means constant slope. Constant slope means constant velocity. Now the question is positive, negative? Positive here. Why? How can I say? Because slope is positive. Theta is positive. No? This is theta. The positive theta. Tan theta is positive. Okay. So velocity is positive. V is positive. Okay. In this one. Another one shall we make? Okay. Another one we will make. Another one we will do here. This is x. This is t. This time we will make the graph like this. With the time, what's happening? You are moving in this way. As the time is passing, when t is 0, you are here. As t is increasing, you are moving in this way. Is it a straight line? Answer is yes. Straight line means, graph is a straight line means constant slope. Yes, it's constant slope. That means velocity is constant. Yes, velocity is constant. Positive, negative? Answer is negative. Answer is negative this time. Why? Because angle is this. obtuse angle. This is acute angle. If angle is acute, positive. If angle is obtuse, negative. So this is negative velocity. If you want to measure it from here, you say that no sir, x-axis I will take over here and I will measure this as theta. Then if you are measuring this as x-axis, then this comes out to be fourth quadrant. Fourth quadrant also tan theta negative. So velocity will become negative. Your wish, no problem in that. Okay. So answer will be same, but it is always better if you take it as obtuse and acute. So if acute angle is there, we will say that tan theta is positive. If it's obtuse, angle is negative. Okay. So if angle is negative means velocity is also here negative only. Right. Very, very important these graphs. Okay. Let's see then what is next in this one, graphs only. So now let's have this variable. Variable slope. So let's make it. Variable slope means like this. X t. Suppose it's like this. Now what you can say here? You can see that slope is changing. Okay. Slope here, suppose theta 1 I am writing. That's theta 1. Now check slope here. You can see that slope is decreasing. xt graph slope is velocity. So if slope is decreasing, means velocity is decreasing. Velocity is decreasing. Okay, one more thing. In the previous cases, all the three cases, first one was anyhow it is at rest. Right? First one was at rest. Second case was a straight line. Third case also straight line. Constant velocities those were. So acceleration was 0 in all the three. Right? But here we are saying velocity is decreasing. That means acceleration is not 0. So acceleration is what? Acceleration is negative. Acceleration is negative here in this case because velocity is decreasing. Okay, acceleration is negative. Okay, fine. Then another one we will make. X t. This time graph is like this. What's happening? What's happening here? You can see that here angle is this one. And if here angle I am going to measure, this is this. It's a big angle. So angle is actually increasing. Angle is increasing. Slope is increasing. Its velocity is increasing. So velocity is increasing. Okay. So velocity is increasing means acceleration is positive. Acceleration is positive. You see that? How these are? Okay. One more we can make. One more. Similar I am making it here. Okay. X and t. How is the graph? Graph is like this time. Okay. Now what's happening here? Now here also, in this case also, if you see, no, slope is basically decreasing. Slope is decreasing. See, here slope is how much? With x-axis. It's a big angle. But here it's almost becoming 0. Correct or not? This is becoming parallel to x-axis. So slope here slope is more. With x-axis, what is the slope? Almost vertical it is, 90 degree it looks like. But here, as it's coming, it's becoming 0. Slope decreasing means, what is that? Speed decreasing. Now, whenever we say speed is decreasing, means what is that? Retardation. Acceleration is in opposite direction. Acceleration is negative. Okay, so retardation is happening. Retardation or deceleration. Why I showed you this? Now let's try and understand one more thing. In this one theta is positive, velocity is positive, but theta is decreasing. We say that acceleration is negative. Velocity is positive, so acceleration is negative. Correct? No doubt about that. Here also you see that this angle, these are positive angles. Positive angle means velocity is positive. Okay, and velocity is increasing. Velocity is positive and velocity is increasing also. So acceleration is positive. Here acceleration negative, here acceleration positive. In this case, velocity itself is negative. Here velocity is negative. It's like this. See the slope coming down. You saw now in the previous case also, when I showed you when xt graph was like this. What I showed you, velocity is negative. So here also, this velocity is negative here. Direction is like this, not like this. Direction is like this. So velocity is negative. Velocity is negative and still speed is decreasing. Retardation is there, true, but acceleration is positive actually. When velocity is negative and still you are able to decrease the magnitude of velocity, then acceleration should be in opposite direction, then only it's possible. Retardation means what? Right? So retardation means is you are changing the velocity. Velocity is in which direction? Negative. So acceleration is where? Positive. Then only you can stop it. Otherwise, how will you stop it? So here you are stopping it. These are also questions. Understood that? So all the three you see. Acceleration negative, acceleration positive, velocity positive, velocity positive, velocity negative, acceleration positive, but still it is retardation. Okay? This is xt graph at the moment. Now let's go on to vt graph. This is a vt graph. Okay, the vt graph again we will start in the same way. Straight line. Okay, so straight line is this. Now as I told you, in graphs we are actually searching for two things. One slope, another one is area. Slope. What I told you, slope is what? Change along y-axis by change along x-axis. So who is along y-axis? V. So slope here means dv by dt. And dv by dt is what? Acceleration. Now area. Area means is multiplication. Multiplication. Okay. V into t. So V into t will give you what? Displacement. So area of VT graph, multiplication. Slope means division. Acceleration, and this gives us displacement. Remember that. Okay. Fine. And this is VT graph. This is straight line. Now straight line means slope means what? 0. Slope 0 means acceleration 0. Acceleration 0 means constant velocity. Constant velocity. If anyone asks you what is the displacement, just put here t, what are the time, t1 and t2, and find its area. That is the displacement. Okay. Suppose this is v1. Okay. So area. What is area? It's a rectangle. So this into this, that means v into t2 minus t. That's all. That is the displacement. VT graph. Let's have another one. V and t. Straight line again, one more time. Right? But its slope is 0? No. Slope is constant. Okay? Slope is constant. When I say slope is constant, means what is constant? What is slope? Acceleration. So constant acceleration. Positive acceleration, that means velocity is increasing. Yes, we can see that here is 0 and here is something else. Velocity is increasing. So its slope will give me acceleration. Okay, area will give us what? Displacement. Suppose anyone asks how much it is traveling. Now it's a triangle. Half base into height. Right? Same way, one more graph if you make. And velocity also, we can make it like this. We can make it suppose it like this. So what it shows us now? Again a constant slope. Slope is constant, but slope is negative. Slope is negative, and velocity you can see it's decreasing obviously. So acceleration is constant but negative. But negative. Okay. Right, in this case. Now let's do a few more cases in that one in which we can get confusion at times. Okay. So what are the cases? We'll make it like this. This is Vt. And suppose graph is like this. Okay. Graph is like this. This one is the graph. What's happening here? Okay, this is negative velocity in this direction, negative y-axis. Okay, so velocity is negative. Right, but what about the slope? Slope is positive. This is the slope, no? Velocity is negative. Slope is positive. That means acceleration is positive. So because of that, what is happening? Velocity is negative, acceleration positive. That means both are in opposite direction. So what will happen? Acceleration works out to be retardation. It will be working as a retardation. So because of that, magnitude of speed you see decreasing. Here it's something and here it becomes 0. Okay. So velocity is negative, true, but acceleration is positive. And acceleration is working as what? Retardation. Magnitude of speed is decreasing. Clear? So these are the confusing graphs. Okay. Variable also, let's see. In variable, so variable graphs V and T. It's like this. What you can say? Here slope is more, here slope is less. Right? So here acceleration is more, here acceleration is less. Okay, variable acceleration. But positive. Why? Because slope is positive. Okay. So variable acceleration but positive, but acceleration is actually decreasing. Here is maximum acceleration, here is minimum. Exactly same way. Increasing acceleration. Acceleration is increasing and it's positive. Acceleration increasing and it is positive. Okay. Right. All right. Let's see then. Now questions. XT graph, and he is asking ratio of VA to VB. XT graph, how to find VA? Slope. Slope. What is VA? This slope. This is this slope. Slope means tan theta. So that means tan 30. VA is tan 30. What about VB? Tan 60. That's all. Over. Okay. So 1030 by 1060. One by root 3 by root 3, 1 by 3. Finish. Okay, that's VA by VB. Then what else? Find displacement in 2 seconds. VT graph. How to get displacement? Area. So area only. Yes. Find area. This is rectangle. Calculate rectangle area. And then calculate triangle area. So what is triangle's area? Half base into height. 1 by 2 into 2 into 1 plus rectangle's area 2 into 1. Answer is 3. 3 meter is our answer. As simple as that. Area of VT graph gives us displacement. Find displacement and distance traveled in 8 seconds. Oh, in the previous question, distance and displacement both are equal. Why? Why in this one? Because velocity you can see is in one direction only, it's positive. So it's moving in one direction. Velocity is not changing. Okay? But in this case, velocity is changing. Here is negative, positive, again negative. So distance and displacement will not be equal. Right? Okay. But what we have to do? We have to find area only, nothing else. So this triangle, and this triangle. That is it. This is positive triangle. These are negative triangles for displacement. But for distance, everything is positive. Okay, so here this triangle is what? Half, base is 2, height is 4. Okay, I am taking everything positive at the moment. For displacement, we will take negative. Okay, plus here also half, base 4, height 4, plus this one now, half, base is 2, height is 4. Okay, this is cancelled, this is cancelled. So what we have? 4 plus 8 plus 4. So distance travelled is 4 plus 8, 12 plus 4, 16 meter. This is distance. Okay. When I am going to talk about displacement, this is minus 4, this is also minus 4, minus 4, minus 4, minus 8, plus 8, 0. So displacement is 0. Remember that. That is the difference between distance and displacement. You can see that it's coming down means direction of velocity is changing. The velocity is becoming negative. Opposite direction. Okay, so this area will take negative. This area will take negative. This area we are taking positive. Right? Find maximum velocity acquired in 2 seconds. What curve? AT. AT curve. Oh, AT curve's area gives us what? So AT curve's area, when you say, what I told you, slope and area. Area means what? Area means multiplication. So area in time, AT, when you multiply, what we are going to get? AT. AT gives us what? AT gives us V minus U. First equation of kinematics, see, I have written V minus U equal to AT. So AT gives you V minus U, that means change in velocity. What it gives us? Change in velocity. So AT, that means area. Area of AT curve gives us change in velocity. Actually, area means is integration. Okay, area means is integration basically. And this is equal to what? dV only, no? We know that. Because we studied A equal to dV by dt, right? From there only it's coming. So integration means what? Area. So area of AT curve gives us change in velocity. Okay. So find area. Area is a triangle only, no? So what is it? Half base into height. So only 2. So change in velocity is 2. That means v minus u is 2. U is given what? 0. So v minus 0 equal to 2. So v is what? 2 meter per second. Okay students, I think time is up. So we finished here today. Little more is there. What is left here is little more questions are there and motion under gravity is there. That you'll try to finish tomorrow. Okay? And today the practice test that will be given, you check that how many questions are there. Yesterday's practice test also you sent me the doubts so that we can take it. Don't worry, if extra class is required, I will take extra class. Don't worry about that. Okay? Don't worry that how we will be completing. No, we will discuss each and every point. I will not leave any point. Okay? We will cover it up. If extra class is required, we will take. Don't worry. Okay students, then we will start from here in tomorrow's class. Bye bye.